is an introduction exercise, and the purpose is to show mass balancing, model calibration, and simulation, as well as the full range of purpose that you can use MedSmart for. Please click on the Launch MedSmart demo icon, and you will have a message which says Welcome to MedSmart. There is also an Excel guide to help you. It's called Demo Help Files, step-by-step instructions. So for introduction exercise, Code of Action B1, click on MedSmart icon. Click OK. Next step, drag the feed belt icon, the sag mill, and the screen onto the flowsheet. Feed belt, sag mill, and a screen. Next step, click on the feed belt, click on the exit port, hold the mouse, and drag the mouse to the feed port of the sag mill and release. Click on the feed belt, click on the product, drag to the feed port, release. Click on the sag mill, click on the exit port, hold mouse, drag mouse to the feed port of the screen and release. Also do this from the oversized port to the feed port of the sag mill. Hold mouse, click, drag to the feed, release. Click on the screen, find the oversize, click, drag to the input and release. This flow sheet has now been drawn. The next step, click on the settings button in the top ribbon, enter the sieve sizes, open an introduction exercise in Excel, and copy and paste the sieve sizes, and then we will click accept. Settings, click to enter sieve sizes. Open the introduction exercise data. Exercise. C. Copy. Click. It must be blue. Control V. It has been pasted. Click there and click accept. The next step is to work in the mass balance. In the demo help file, it says click the enter survey data button in the top ribbon. Click on include exclude assays and deselect the checkbox. Enter survey data. You are working in the entry of plant survey data section. Include exclude assays, deselect. We are not working with assays in this case. So we are finished with B14. and B15. The next step, in the Survey Rates tab, enter the information from the Excel sheet. Survey rate measurements. In the Excel sheet, we can see the SG is free. The feed rate is 110. And the accuracy is 10. 10 is for a very accurate number. Survey percent solid measurement. So we have completed that data. Click on the Survey Percent Solids tab. Enter the percent solids and accuracy information from the Excel sheet. "100", accuracy 10, percent solid 72, accuracy is 7, oversize 99, accuracy 7, undersize 0. We could not measure this. Accuracy is 0. Now, click on the Survey Size Distribution tab, enter the sizing data and the accuracies. Copy it from Excel and paste into the table. For the accuracies, we'll use the accuracy of 10 for the feed, 7 for oversize and undersize, 0 for the SAGMAL. So survey size distributions. Okay. I will go to my introduction exercise plant survey data. Select the feed product, Control Copy. Click once, Control V, paste. Accuracy 10. SAGMAL product was not measured, accuracy 0. Screen oversize, Control C. Software, Control V. Accuracy 7. Undersize, Control C. Software, paste, Control V. Accuracy 7. Click Accept. Save. I will save this on the desktop and it will be called Intro Exercise. Save. So we have clicked Accept. Now click the Mass Balance button to start the mass balance. Click OK on the message, and then we will look at the results. Click on the mass balance result, and then view the tables and graphs, and then close the screen. Survey equipment data, mass balance. So we click mass balance. The mass balance has been completed. Click OK. Click on mass balance results. You can view mass balance results in this section. Here is the mass balance table. It has calculated missing information. You can view the size distribution graphs. You can export to Excel or PDF. The mass balance section has been completed. Next, we will build a mathematical model in the Calibrate section. First, we must enter our survey equipment data. This is information collected during the survey. So in the introduction exercise file in Excel, you will find the information for the SAGML and the screen. Okay. So diameter 5, length 1.5, cone angles 5. Five, 1.5, 5, 5. Open area was 10. The grade opening was 25. The installed motor power was 600. The ball load was 12. This top size was 125. And the speed was 75. The power draw output was 475. The mill level was 26 and the slurry level was 100. For the screen, the length was 4 meters, the width was 2 meters, maximum flow 2000, and the operating variable was the aperture, the opening size, and that was 12 millimeters. This information has now been set for the survey. Click Accept. We clicked Accept button. Now click the Calibrate button in the top ribbon and then view the results for the full calibration. So I click on Calibration Results. You can view calibration results in this section. Oops. And here I can see my full table of results as well as my calibration constants. These constants are the signature numbers explaining the behavior of these equipment pieces. I can see the size distribution graphs as well as specific calibration graphs for each of the equipment pieces. This concludes building a model for your plant. The next section is simulation. So first, we will click the Simulation Conditions button. Then we will exclude size assays and we will include size distributions. And then we will reset our survey conditions and our calibrated model parameters. So we will click Transfer Survey Conditions and click Transfer Calibration Results buttons. Simulation conditions. I will include size distributions. I will not have an assay, and I will transfer my survey conditions. The survey conditions from the plant survey has been entered, and I will transfer my calibration numbers. This simply means that the survey conditions have been transferred to save you time. In the Help section, B44 says enter your new feed conditions. It asked for a new dry rate of 120 tons per hour, SG of free, 100% solids, and a required P80 of 100 mm. So 120 free, 100 mm, 100% solid, and 100 mm on the feed. I will use my survey feed size distribution, Control C, go to the software and press Control V to paste the size distribution. Next, I will click on my operating conditions for simulation. So this section has been completed. B45 has been completed, and I've clicked on the new operating conditions for simulation. Here it asks for a new impact index of 60 and a new abrasion index of 75. 60, 75. Please note that the percent solids have not been entered. Click 72% for the SAG-mill, 55% for the screen. This is for the undersize of the screen. Okay. These two numbers must be entered or the simulation will not work. Check all the results you've entered or all the data entries and click Accept. So we finished B47, we finished B48. Now it says click the Simulate button in the top ribbon and then click OK when it has simulated, and then view the results. So I will start the simulation up here, click Simulate, and it tells me that I have some problems. A red button is a problem. So next I click on Simulation Results and I view the full results. The stream results, click on Simulation Output Results and view the results. Click on the Simulations tab to view the warnings and errors, and then close the screen and close MetSmart. Here I can see with these conditions I will have a total filling that is too high, and I will have slurry filling that is too high. This concludes the introduction exercise. The purpose of this exercise was to draw a flow sheet, to learn about mass balancing, model building and simulation, and on how to enter data. The next exercise